Shri Gurubhyo Namaha children. Welcome to our online teaching Ekalaiva. Today we are going to learn 10th standard science heating effect of current. So what is this heating effect of current? When an electric current is passed through a resistance wire which is having a very high resistance, suppose for example let us take a nichrome wire. So the resistance wire becomes very hot and it starts producing heat. So this effect is nothing but you call it as heating effect of current. Now the heating effect of current is obtained by the transformation of electrical energy into heat energy. So since a conductor, suppose let us take a resistance wire. Now it offers resistance to the flow of current, yes or no? So it will not allow the current, it will resist the flow of charges. So what does this current has to do? The current has to do some work continuously to keep itself flowing. So what is the work done by the current when it flows through a resistance R for a time t? That is what we are going to see now, right? So when an electric charge moves against a potential difference V, the amount of work done. So potential is work done per unit charge. Now this formula you are familiar with. Now I am going to write what is the work done. So work done is of course Q into V. Okay, I just rearrange this formula. Similarly, we also know the formula for current. Current is nothing but rate of flow of charges. I is equal to Q by T, or from this I can also write Q is equal to I into T. Okay ma? And we also know the formula for resistance. Okay, resistance from Ohm's law. So from Ohm's law, we have resistance equal to R equal to V by I, or I can also have V is equal to I into R. Okay ma? Now I am going to substitute Q is equal to I into T and V is equal to I into R in this equation. Okay, work done equation. Now let me take this equation as 1. So substitute now. When I substitute, W is equal to I into T. For Q, I will substitute I into T. For V, I will substitute I into R. So here is the equation for the work done. Work done will be now I square R into T. Okay. So what has been done here? Now the electrical work done or the electrical energy consumed, that is whatever current has been given, is converted into heat energy. Work done is nothing but what? Here work done is energy, right? But here what type of energy? Here it is heat energy. So I will write H is equal to, H represents heat. So work done is nothing but heat energy. So here I have the formula for heat energy as H is equal to I square R into T, and we know that work done is measured in joules. So here also it is measured in joules. Heat energy is H is equal to I square RT. Okay. So this is the heat produced when a current of I ampere flows in a wire of resistance R for time t is equal to t seconds. So this is nothing but you call it as Joule's law of heating. Joule's law of heating. H is equal to I square RT. Okay. So from this formula, it is very clear. Okay, so look at the terms in this formula. I square, which is current, R is the resistance of the wire and T is the time taken. Okay. So we can clearly understand from this equation that heat produced. Now let us take the first term here, children, which is current, and that too square of the current, because it is I square. So we can say that the heat produced, okay, is directly proportional to I square. I square in the sense square of the current, which means, suppose let us say if we are doubling the current. Okay, ma. So initially, let us take the value of current to be 1 ampere. Now I am going to double it. So if I double it, what happens to the heat also here? The heat also will be 4 times, because I is equal to 2 ampere. Now here I am going to substitute as I square, which becomes 4. So heat produced will become 4 times. Okay. Suppose let us reduce the value of current. Now instead of I, it becomes I by 2. Okay, you just decrease the value of current, then the heat generated will become 1/4. So if this is increasing, this also will increase. If current is decreasing, heat also will be decreasing. So H directly proportional to square of the current. Similarly, H directly proportional to next term. What is the next term here? R, resistance. So if we double the resistance, now here resistance is considered to be 1 R. So heat is also 1 H. Suppose if I am going to double 2 R, so heat also will become doubles. If I am reducing the resistance becoming R by 2, the heat produced also will be H by 2. So it has a direct dependence. Greater the resistance, greater the heat. Lesser the resistance, lesser will be the heat. Okay, ma? Right. Next, what is the next term, children? H is proportional to T, which means now the current is passing through the wire. If the time is doubled, heat produced also will be double, and if the time is going to be halved, the heat produced also will be. Now all these terms it is directly proportional to heat. So whichever value is increased, naturally heat also will get increased. So this is about Joule's law of heating. Now you have to study more about this in your higher classes, but just as far as your class is concerned, just I wanted you to know this formula. H is equal to I square RT. Now this law will be applied in all your higher classes, 11th, 12th. We are going to talk much more in detail about this Joule's law of heating in 12th standard. So this formula is very, very important. You should remember this formula very well. Okay, ma? Right. Next, we are going on to the applications of heating effect. So where are the areas where we apply the concept of heating effect? That is Joule's law of heating. Where is applied? Now it is applied in many important applications in our for our domestic purpose and for industrial purposes also. Now all these things, now look at this. Now these are all the electric heating devices that we use in our daily life. Now this is a geyser, this is a toaster, now this is an electric iron. Now all these produces heat energy. Yes or no? So what is happening here? How the Joule's effect is used here? Okay, so it is utilized in all these electrical appliances. Now these electrical appliances, now they have a heating coil inside it. Okay, so this heating coil, they have very high resistance. Okay, so greater the resistance, we saw if the value of resistance is going to be very high, the amount of heat energy that is produced by these electrical appliances will also be very, very high. Okay, so all these materials will have what is called as a heating coil. So that heating coil, now this heating coil will have a very high resistance. Okay, so when you pass electric current, the amount of heat energy that is produced by this heating coil will also be very, very, very high. Okay, so we use what is this resistance made up of? Now this resistance is made up of an alloy which is called as nichrome. Okay, so nichrome is the combination of nickel and chromium. So almost all the electrical appliances will have this nichrome, okay, as a heating element. Now heating coil, or otherwise you can also call it as heating element. Okay, heating element made up of nichrome. So why we use nichrome wire for all these things is, now nichrome wire is considered to have very high resistivity. Okay, so it has got very high resistivity, so that it produces more amount of heat. Okay, similarly it has a high melting point. So the melting point of nichrome wire is very high, so we use nichrome wire has heating element. When a very high heat is supplied, the wire, it will withstand the very in the heat, it will withstand the current that is passing through it. So definitely if the material is going to have a low melting point, that definitely it will melt when a very high current is passed through it. So definitely it should have a very high melting point. Next, third one is, it is not easily oxidized. It is not easily oxidized. So these are the 3 points why we choose it has a high melting point. Why we choose nichrome wire. All these 3 points are very important, children. These 3 points are there discussed in your textbook. So I want you to just go through that. It may come as a 2-mark question. Okay, ma? Now next is fuse wire. Now here we have nichrome, which is used as a heating element to produce very high heat. Okay, and why do we use nichrome wire? It is also discussed. Now next we are going to the next application of heating effect, which is used in fuse wire. So how this fuse wire, now you know this fuse wire is connected in an electric circuit. Domestic appliances where we use electrical energy, there we have this fuse wire. Okay, so what happens here? Why do we use a fuse wire? Now whenever you have a large current passing through a circuit, now this fuse wire, it will melt. Now as far as fuse wire is concerned, this has got a low melting point. Now why does it has a low melting point? Now the fuse wire will be connected in between this contact. See here, this is a contact, this is a contact. Now in between this you connect the fuse wire. Now this fuse wire is considered to have a very low melting point, so that when a high amount of, suppose in a electrical circuit, whenever there is a very high flow of current, immediately what happens, the current is transferred here. So the fuse wire, what happens, it takes the current. Since it is a very high current, immediately the wire will melt, and this fuse wire will be connected to all the domestical appliances. So when high current is flowing in between this wire, so what happens, the fuse wire will melt and entirely it breaks the circuit, so that the passage, the flow of electric current is stopped, so that the electrical appliances are saved. They are saved from any other damage. Okay, so this is why we use fuse wire in electrical circuits. Okay, ma? And the third application of heating effect is filament in bulbs. In electric bulbs, you have a small wire which is called as filament. Again, this filament is made up of a material whose melting point is very high. It should withstand the heat that is produced by the current. Usually, what wire is used as a filament means, here we use tungsten. Tungsten is the material which is used as the filament here, and this also will have a very high melting point to withstand the heat. Okay, ma? So whenever current is passed through this wire, heat is produced. Definitely you have heat produced in the filament, and this heat is converted also into light. It glows out, the filament produces light, and we use tungsten as the filament which is used in electric bulbs. So these are some of the applications of heating effect, Joule's law of heating. Okay, so with this we are moving on to what is called as electric power. Okay, so what electric power, and also we are going to discuss about electrical energy. Okay, ma? So first let us talk about electric power. So what is power? Generally, we define power as power is nothing but we define rate of doing work. Rate of doing work is nothing but you call it as power. Okay. Now when we talk about electric power, so electric power is also defined as the rate of consumption. Consumption is usage. Okay, ma? So consumption of electrical energy. Now we pay to the electricity board for the electrical energy that we use, not for the current. Okay, ma? It is for the energy we pay the amount. Whenever you have current bill, how much is the current bill? Means suppose you say in units. Okay, so that is nothing but the electrical energy that is measured. So electric power is nothing but rate of consumption of electrical energy. Okay, right. Suppose let us consider a current I flowing through a conductor of resistance R for a time t. Now we know the formula for work done. Just now in Joule's law we discussed work done is nothing but V into I square RT we discussed, and this is also the work done formula. Work done is equal to V into I into T. Okay, so work done is power. So power is written as power is equal to, power is represented by capital P, children. So it is work done, rate of work done. So rate of work done means with respect to time. So work done is V into I into T and divided by T. So T and T gets cancelled. So here is the formula for power, which is the product of potential difference into current. V is the potential difference or voltage. Okay, voltage into current. Okay, now this is one formula, right? I'm going to give two more formulas for power, okay, in terms of current and resistance. Now we all know Ohm's law. Now as far as this is concerned, electric power is nothing but the product of, it is the product of electric current and potential difference. This is one formula, right? Now we all know the formula for resistance based on Ohm's law. V by I is equal to R, or I can also write this as V is equal to I into R. So when I substitute for V is equal to I into R, what is the formula for power? Substitute P is equal to V into I. Substitute for V as I into R. I into R into I. So here is one more formula for power, which is I square into, sorry, should be square, children, I square R. So this is the second formula for power, right? And again the same Ohm's law I will take. V by I is equal to R. Or I can also write I is equal to V by R. Yes or no? Now substitute again in this formula. P is equal to V into I. Substitute for I as V by R. So in this case, the value, the formula for power will be V square by R, equation 3. So here are three formulas for power. P is equal to I square R and P is equal to V square by R. Now all these are formulas are for power. All these formulas are used for solving numericals, children. So according to the data available, you can use these formulas to find out the value of power. Okay, ma? And what is the SI unit of electric power? The SI unit of electric power is what? SI unit of power. SI unit of power is what? WATT. Okay. So the power is said to be 1 watt when a potential difference of 1 volt is applied to pass a current of 1 ampere. So when an electric device is operated at a potential difference of 1 volt and if it is carrying a current of 1 ampere, then the power is said to be 1 watt. Okay, and for measuring electrical energy, we will not use the SI unit of power. Instead, we go for what is called as kilowatt. Kilowatt is the unit of power which we use for electrical energy. Usually electrical energy, that is the usage or the consumption of electrical energy, is based on two factors, children. One is the amount of electric power that is there and what is the duration of usage of this electric power. So I can have the formula for electrical energy as, okay, so electrical energy is nothing but the product of power, that is electrical power into, that is let me write here, children, otherwise electrical energy is power into time. Okay, so E is equal to P into time. So now here I told you power is measured in terms of kilowatt. So kilowatt hour electrical energy, the commercial unit of electrical energy is kilowatt hour. Now this you can see in your electricity meter board. There is a green color meter board in your electricity board, you can see. Now in that, whatever units you measure, now a person from electricity board, he will come and take the reading and he will give you the reading. For example, let us take 200 unit. They will say 200 unit in the sense it is nothing but 200 kilowatt hour. Okay, 1 unit, that is this kilowatt hour is 1 kilowatt hour is 1 unit. Suppose the amount, the units come to 200 unit. Now the government will fix the rate for 1 unit. Suppose let us take the amount for 1 unit is 7 rupees. So in that case, how much amount of units, how much is the units that is consumed? So multiply by the rate for 1 unit, you will measure the value of electrical energy. So you pay your bill for the electrical energy that is consumed. So 1 kilowatt hour. Now 1 kilowatt hour is, kilowatt is 1000 watt hour, right? 1 kilowatt is 1000 watt. So 1000 watt hour. Okay, ma? So I will measure 1000 into, now convert this hour into seconds. So it is 60 into 60, 3600 seconds. So what is the value of 1 kilowatt hour is 3.6 into 10 power. It is equivalent to 3.6 into 10 power 4 joules. Okay, so 1 kilowatt hour is 3.6 into 10 power 6 joules. Okay, so the electrical energy and the commercial unit of electrical energy is kilowatt hour. Okay, you are able to understand, children? So next class we will be learning about domestic electric circuits. So please go through the notes that is given in your textbook on this topic, electric power and electrical energy. Now all these topics will be continued in your higher classes also, children. So please make a note of all these formulas and about this electrical energy, how electrical energy is consumed, what is the SI unit of power, what is the commercial unit for electrical energy. All these formulas are very, very important, children. So please go through the notes and we'll be continuing with domestic electric circuits in our next class. Okay, thank you children.